Welcome back, everybody. Today I want to talk about the chain rule. This is probably the worst thing, like the worst case I've seen of a school system teaching a rule without any explanation of where it comes from or why it works, right? You're told for the chain rule, you have f of g of x, it's f prime of g of x times g prime of x. Where the heck does that come from? Basically, no one ever knows. So that's what we're going to be talking about today. So naturally, what we'd like to say, it'd be nice, if we had f of g of x, the derivative, f prime of g of x. That would be nice, but that doesn't exactly work, and here's why. We look at it in terms of the difference quotient. We have our derivative of f of g of x. We're going to have our input being x plus h here, and still just x here. And so we get this f of g of x plus h minus f of g of x. Now, the problem with it being equal to just this, right, our f prime of g of x, that would be true if it was f of g of x plus h on the outside, right? F of g of x plus h like this. But that's not the case. The plus h is inside the g of x as well, and so it offsets things. Okay, so hopefully we can understand why this equality can't be true. The differential of f of g of x just can't be f prime of g of x. It just doesn't work. So we're going to cheat a little bit, and we're going to examine what it does equal ahead of time so that we can try and think of an intuitive solution for it. So we know by the chain rule that the derivative of f of g of x is f prime of g of x times g prime of x. So, to actually figure out what's going on here, we're going to use two substitutions. We're going to call a function y equal to f of g of x, and then a function u equal to g of x. And we're going to examine how this affects things. Okay, so we have our substitutions up here. And if you recall the earlier expression, the derivative of this is going to be dy dx. Now, it's going to be equal to dy du, where u is our g of x. Basically, that means f prime of u, where u is g of x, so it's f prime of g of x, times du dx, which is just going to be g prime x. All right, so we see that this expression must be equal to our end result. This is what the chain rule tells us. Now, these look like fractions, and wouldn't it be so nice if we could just cross here and cross here, dy dx, dy dx, duh, obviously it's true. But technically we don't know that. We don't know that yet because, if you recall from the previous video, what du dx or dy du or d something or other, it just means as you take an infinitely small chunk on the bottom, you get a certain infinitely small chunk on the top, which means that the infinitely small chunk of du that we get when we take dx might not be the exact same as an infinitely small chunk of du. We don't technically know that for sure yet. So that is what we're going to have to prove. So we have our product dy du times du dx. And so the product that's going to get us here is this section is our dy du, where we have y of, since y is technically a function of u, we're calling it, y of u plus h minus y of u, that's our dy. U plus h minus u is going to be our du. So we can cancel these two, right? That's our difference quotient, right? Now, du dx, u is a function of x, but it's also equal to g of x. So that means that it's g of x plus h minus g of x. And then, of course, these will cancel, just like up here. Now, here's the thing. Since u is equal to g of x, du dx must be equal to dg dx. And this h is equal to du. We know that this h is u plus h minus u. It's du. So we know that's du. That's great. But what is also du is dg, right? Du has to equal dg. So, since dg is the limit as h approaches 0 of g of x plus h minus g of x, that's exactly what dg is, this must also be du. And since we're multiplying the limits, the product of limits is also the limit of products. So when we multiply it together, we have du here, and on the top over here, we have another du. And so when we multiply them, they are inevitably going to cancel. And we know this is dx, and this is dy. Then we have the limit as h approaches 0 of dy dx. So this is equal to dy dx. And of course, how did we get here? We started by multiplying dy du by du dx, and we found that they were equal. Therefore, dy dx is equal to dy du times du dx. And that's what the chain rule tells us. So now we've proven it, and there are so many things that the chain rule is important for. The idea of a composite function is so incredibly important for anything, really. Even if you have like 2x squared, that's technically a composite function, right? So it's incredibly useful for finding derivatives of more complicated functions. But this is where it actually comes from. This is the general formula. Dy dx is going to be dy du times du dx when it's a composite function like this. And we've proven it. So thank you so much for watching.